In this video, let's take a look at infinite geometric series. So we'll start by looking at a couple of problems. So for example, does this sum 2 plus 8 plus 32 plus 128 end up having a value? Well, if we keep adding larger and larger numbers, it doesn't seem like it will actually ever end. So in this example, no, as the number of terms increases, not only the number of terms increases, but the value of each one increases. The sum of the series also continues to grow. So when this happens, we call this a divergent series. Divergent because it's going to keep going on and increasing larger and larger. Now, if we take a look at the second sum, we have 32 plus 8 plus 2 plus 0.5. We can see that this geometric series, the numbers are getting smaller and smaller. Now, it seems like it will never end as well since it has the dot, dot, dot. However, because the numbers are getting smaller, this actually will converge to a sum. So yes. So as the number of terms increases, the sum of this series approaches a fixed value. And I'm going to show you how to find this fixed value. So in this series, we call this one a convergent series. So let's consider the formula of a geometric series. So that is S of n equals T1 times 1 minus r to the n divided by 1 minus r. Or you also might know this as Sn equals T1 r to the n minus 1 all over r minus 1. So basically they're the same, and just by factoring a negative 1 in the numerator and the denominator. Now, in other formula, as n increases, okay, so as this value n increases to infinity, then this r to the n will approach 0. However, it will only approach 0 if that ratio is between negative 1 and 1. So let's say, for example, that r is a half. Okay, so as n gets bigger and bigger, so let's say it was power 2, we get 1/4. If half to the power 3, then we get 1/8. If it's half to the power 4, we get 1/16. So you can already see that as half the exponent increases, the fraction is getting smaller and smaller and smaller. So it's going to approach 0. So this only happens when the ratio is between negative 1 and 1. So because of that, we can actually reduce this entire formula, S infinity, to be T1, because the r to the n will become 0, all divided by 1 minus r. And this is the formula that we can use to find the sum of an infinite geometric series. T1 is still our first term, and r is still the common ratio. And it's a nice little formula because we don't need to know n, because n is going to increase to infinity. And then that's it. So let's take a look at some examples. All right, so we have this first example, and let's list what we know. Oops. So we have T1 equals 12, and our r value, remember, we can get by 6 divided by 12, second term divided by first term, or the third term divided by the second term, so 3 divided by 6. Either way, we're going to get a half. So the sum of this infinite series is going to be 12 divided by 1 minus r, which is a half. So we have S infinity equals 12 divided by a half, and 12 divided by half is equal to 24. All right, let's try another one where the signs alternate from positive to negative. So here we have our first term is 15, and then our R value is negative 5 divided by 15, which is going to be negative 1/3. So the sum of this infinite series is going to be 15 divided by 1 minus negative 1/3, so it's going to be 1 plus 1/3. And 1 plus 1/3 is 4/3. And if you want, we can change this to 15 divided by 4/3, or 15 times 3/4. So we can get a fractional answer. 15 times 3 is 45/4. I'm going to show you another example where we can take a repeating decimal and treat it as an infinite geometric series, and then it will actually be changed into a fraction. So let's say that we have 0.584, which is all repeating, and we can actually represent 0.584 as 0.584, 584, 584. However, we can also represent this as 0.584 plus, and then if I want to omit those first three numbers, it'll be 0.000 and then 584. However, if I want to omit these six numbers, it'll be 0.000000 and then 584 and so on. And this will give me the repeating decimal. So if I want to write this as an infinite geometric sum to be found, I can write this as T1 is 0.584. And the ratio, I'm actually going to set this up as a fraction. So remember, we take the second term. So it's going to be 584 over 1,000,000. And that's going to be divided by 584 over 1,000, which is my first term. So simplifying this, by multiplying by the fraction, I have that the 584 cancels off, and then 1,000 goes into million, 1,000 times. So now I have 1 over 1,000, and that's my ratio. So the sum of this infinite geometric series is going to be 584 over 1,000. That's my first term, all divided by 1 minus 1 over 1,000. And 1 minus 1 over 1,000 is going to be 999. So I have 999 over 1,000. So instead of writing it like this, let's write it out horizontally. So when I divide by 999 over 1,000, that's the same as multiplying by 1,000 over 999. And the thousands cross off. So I have 584 over 999. And now I've changed 0.584 as a repeating decimal to a fraction.